We get to the other topics, as I realized once you guys started doing your homework that I forgot to cover that style problem.
Figured it out.
Yeah, I know a majority of you came up and asked about it and kind of worked on it, but I'll show you the official way, I guess. Well, I say official way, but any way you can get it to work correctly is fine. There are three methods to doing this. This only works if you have a monomial in the denominator. So I don't know if you guys remember what a monomial means. It just means one term. So like you can't say, it can't have a plus or a minus another term. As long as you have a single term in the denominator, there are three methods. One method is going to take the individual terms on the numerator and split them up. So this one you can rewrite as 8x cubed over x plus 4x squared over x minus 3 over x. Now for some people this makes more sense. Like that's really the only difference between the different methods, is that one of them will most likely just make more sense to you. So in this instance then, like there's an x on top and bottom, so you can reduce them. Same with here. And then on the third one, that is the only x. So then you would rewrite it as 8x squared plus 4x minus 3x to the negative 1. And then be able to do the power rule. So that's one method. Let's see if I can fit all three methods up. Oh, I guess I should ask questions first. Feel free to ask along the way if I put something up there that didn't make sense. I also probably skipped why we even have to do this. You're not allowed to take the derivative of top and bottom separate. And I know some people were wanting to try that, but that doesn't work. The power rule only works just one line variable to the power. Okay, second method. Some people prefer, like this one's actually a pretty common one over the years. I think that may be because they must show this in pre-calc or something, I don't know. But the second method that I've seen quite a few students use is to bring the denominator up to the top and multiply it out. So like distribute it. And when you distribute variables, like when you multiply two variables together, you add their powers. So this first one would be 8x3 plus negative 1, 2 plus negative 1, and then 3 times x to the negative 1. I would say these are the two most popular methods. And for the most part, one of the two usually just clicks with you better. The third method is pretty much exactly like the first method, except you don't actually rewrite it. The third method is you just divide each term by x. So the third method gives you the same answer, but you just know to divide each one without actually separating it. So like, when I would look at this one, I would know this would become 8x2 because I would subtract 1 power. This would become 4x1 because I would subtract 1 power. And then I know 3 over x. I can't divide, so then I would just write them as a single one. All three methods work the same. It's just kind of like different perspectives. Oh, you're asking a question. Yeah, go crack away, yep. Although then you're gonna end up like me when you get older, then things don't want to crack anymore and it hurts. I was an avid knuckle cracker, and now my fingers are not friendly to me. I don't know, any questions on that? Is that pretty much what you guys ended up doing on your own anyway? Maybe you approached it differently or something, I don't know. Okay, well then we'll get to the new topic. For the most part, I know you guys are pretty terrified of trig. Here's the really good thing, is that derivatives of trig have nothing to do with like evaluating trig. Like, I think what you guys don't like about trig is having to do like sine of pi thirds, things like that. There's no evaluating at all in derivatives. There's just answers. So the derivative of sine of x is cosine of x. The derivative of cosine of x is negative sine of x. And it feels like there's a pattern until you get to tangent. And then the derivative of tangent is secant squared. So if you have to do a derivative of a trig function, you're not going to be evaluating anything. You might have to at the end, I don't know. But you're just actually writing the answers. These are far easier than power rule because the answer is predetermined. You don't do anything with it. You just know the answer already. I think down below is just calculator, right? Yeah. Nope, skipping that. And I don't want to go through this. That's just basically proof of the trig stuff. That's the long way to find the derivatives of sine and cosine. Here's the last two derivatives we're going to learn. The first one is awesome. If you have e to the x, the derivative of e to the x is e to the x. By far the best one out of all of them, which is super weird. The slope at every x value of e to the x is the exact same as its height. So like if your point is at a height of 2, it would currently have a slope of 2. Every single point on the graph works that way. It's really strange. But it works great for taking derivatives. If you have a natural log, then the derivative of a natural log is going to be 1 over the x value that you were plugging in. Now that only works if your value is positive. That's kind of like a given because natural logs can have negative numbers in there. You can have negative answers, but you can't evaluate the negative number. Okay, so let's do some of these. Now, here's the natural log part that you guys are going to use. I bet you don't remember all of the properties of natural log, which you kind of need to. Like, they're supposed to be just ingrained into you by now, and I know every single year they're not. Does anybody remember the property if you have a power inside of a logarithm? You can bring it out front as a multiplier. So this would be rewritten as 3 times ln of x. Well, okay, so now I'm going to do the derivative. Any kind of a numeric multiplier is going to be followed into the derivative. So if I had a times 3 in the original function, my derivative will also have a times 3. And then I need to do the derivative of ln of x, which is 1 over x. So then that would be the derivative. By far the hardest part of today's is going to be remembering all the natural log properties. So that's why I kind of figured we would go through a bunch together.
Why is ln of x 1 over x? Do that.
Like, you want to know why that's its derivative?
Yeah, I don't know how.
It would be a ridiculously long explanation.
Oh, so just like memorize it.
Yes. It's not something that should be intuitive.
Okay.
Is that kind of what you're asking?
Yeah.
Oh, yeah, no, it's not something I would just expect you to know. It's just the same as the derivative of sine. I'm not expecting you to, like, be able to figure out how come it's cosine. It'll just be something you memorize. So the power rule for right now is the only thing that you need to know how it works to be able to come up with an answer. The trig derivatives, e to the x and ln of x are all just memorization ones.
Okay.
So is the movement of the three at the beginning just the thing that we should know how to do? I know.
That's one of them. The rest of them are in the rest of the problems. Like, the very next one, we've got a natural log of multiplication. So the first property that we're going to use is that this can be rewritten as ln of x squared plus ln of e to the x. So if you have multiplication, you can rewrite it as two natural logs added. And then we're going to try to simplify all these before we actually do derivatives. So you'll notice both of these have an exponent on it. So both of these, I'm going to bring the exponent out front. Like, I haven't even done a derivative yet. I'm just trying to rewrite the original one simply. So this would be 2 ln of x plus x ln of e. Remember that? 1. Yep. ln of e is 1 because this is like, say, I'll erase this, but this is like saying log base e of e. So in your head, you're saying e to what power is e? Is 1. Okay? So, 1. And this is about as simple as I can think to make this one. So now I'll do derivative. So g prime, which is the derivative. I see a multiplier, so that means my multiplier is going to follow with it. Derivative of ln of x. So that's my first answer. A plus sign means I'm going to do another derivative individually. So derivative of x. Remember that one from yesterday? Not 0. 1. Yeah, derivative of numbers is 0. Okay. So if I wanted to simplify this or write it differently, 2 over x plus 1. I'm not even sure if they'll write that as the official answer or if they would common denominator. Don't know. It's up to whoever's writing it. Plus, if you looked at the answer key, you probably noticed that most of the answer key answers are written like an official simplified version. Okay, that would have a lot of things. Are we okay with that? Is it just a fact of you probably need refreshing on all the properties? Should I have somebody answer this? Are we feeling confident enough to call on people? Andrew? How about C? Can you help me out with C? Oh, that's right. Like that? Yep. How do you do the derivative of that? Which is why I'm having you guys answer this one, because it feels weird because that answers that, but that's right there. We did this one yesterday.
Oh, it's to the power of 3.
Correct. So instead of having 1 over x, you can write it as x to the negative 1, and then its derivative would be the power rule. So what would it become? But this is by far the hardest part, is just getting things mixed together in your head. Once you start learning so many different things, are you trying to help them out? How come? Oh, okay. Or did you change your mind?
Remove the negative one to the front.
Are you trying to do the power rule?
Yeah.
Then yeah. You're the worst whisperer ever.
Okay.
Okay, so yes,
He said.
if, I know what you were probably thinking of x to the first power, yep. So we've got x to the power, so power rule would be move the negative one in the front, which would make that a plus. And then you subtract one from the power, which will become -2. Okay, so that's the derivative. I can write the answer a whole bunch of different ways. One way is I could write it like both with powers. One way I could write it both with fractions. Another way is I could combine the fractions. This gets super annoying after a while. It's at the end. Correcting your tests is horrible because there's a million different ways to answer things. If I common denominator this, then this would be x plus 1 over x squared. All three of these are equal and correct. Makes my job hard. And they all look very different. You feel like you could tackle D on your own? Do you need refreshing about the division property? Yeah, I figured you probably remember this after seeing the multiplication one was addition. That those can be subtracted. See if you can come up with this answer on your own. It's got a lot of stuff. Work with people value, you know, whatever. Sounds like somebody forgot to shut off their ringer. I heard Snapchat go. It's a common beep during tests. Always one person that forgets to shut off their ringer.
Okay, so we would be 2
Why do you guys avoid one?
Explain to me again what you did with the constant. Oh, that's multiplication, so you can put that on together.
Isn't it? It turns into 1 over 3x.
Ln of v, remember ln of v is 1.
Yes.
So that just becomes 2.
What did my ego?
2x minus 1 over 3x? Or 1 over 3?
Oh, wait. ln 2 times ln
1 over
ln is 1, so, oh, you just skipped a
And
step.
then are both those
I-
derivative?
Wait,
We need to find the derivative.
Now we need to
Put
find
it in the
this.
X.
Now we need to find the derivative.
I thought that is the derivative. We found the derivative of this one, not this one.
Yeah, that's what it is, so it's X times
Okay, so we
oh, yeah, X is separated before you
So we took the derivative of the second.
I was like, okay,
first
I was
one.
like, what's it supposed to be with the extra X?
How do we find it?
There's a lot of places.
It's just like straight up. Just
I know, but I feel
It's got a lot of different stuff.
Is you know how it's like
It didn't, it seemed like it should be an innocent problem
Then you
for,
have to like subtract 1, that becomes 0.
Oh yeah, it's just.
How you
Next,
like
wait, oh wait, you did
separated it, like how you're.
1 minus, yeah. Wait, what?
say it again,
Can you just go through how you broke the first thing down?
the first thing in the upper right.
Because
So, because you've got natural log of division, the very first main property, is that you can rewrite it as ln of the top minus ln of the bottom. So that was that right there. The top, instead of me writing it as 2ex, I wrote it how you should view it, which is 2 times e to the x, and then 3 times x. And then because they're both multiplication, I can separate those as addition.
And you didn't separate the second one as addition.
I did. The second one,
This one's 3 times x out of the.
yep, I understand. Because this subtraction is on the whole thing,
Oh.
you have to distribute the minus sign to both of them once you separate it with addition. That's why there's 2 minus signs. And then these seem strange, but the derivative,
So
ln of 2 is just a number, so its derivative is 0.
ln is just, yeah. ln is 0. ln x is 1.
He's doing the purpose.
It's just 1 minus 1.
Yeah, as soon as I write y prime, then that means I did the derivative.
And so it's like, it's just some number.
ln of
There's
2,
no x, and you can't
correct.
do it.
ln of 2 and ln of 3 are both just
It's
actual
just a
numbers.
constant number.
It doesn't seem like they should be, but they're numbers. You can type them in your calculator, it'll give you a number answer.
So it doesn't matter what number, because it's a constant, so
Correct.
it's derivative.
Correct.
So yes.
Oh, I thought you were raising your hand. That's all right.
Could you explain the x ln e equals, like derivative of x ln e to 1? What is it?
Oh, so ln of e is 1. So this currently says x times 1, which is just x. And then the derivative of x is 1.
Oh, okay.
It's partially simplifying along the way and using logic through all of it, which, I mean, a lot of people ask why they should take calc, and there are different reasons. One, it might be the basis for whatever you're going into, okay? Two, a lot of employers will hire people who are good at math because they're good at using logic for a variety of situations. Like, derivatives is not something you ever did before, but you were still supposed to combine like the different properties you learned in pre-calc algebra 2 on natural logs, along with something new that you just learned, which is derivatives. So it's kind of all about using your brain in a logical method. And that's why a lot of people like to hire people who are good at math, even if the job is nothing about math. It's just because you have taught yourself how to think in a logical way. This is a really good example of that. There's a lot of things going on, even though its final answer isn't much. Okay, are we still unpacking that one? Should I wait to go on? I like how we have half the class, but I'm getting even less feedback, which I was kind of expecting more feedback. It's supposed to feel easier to talk when there's less people. It's not. Okay, you guys are awesome, thank you. Okay, I'm gonna skip E because it's pretty much exactly like some of the other ones. Let's go to F, because that one looks terrible.
It's just 3x.
Does anybody want to take a stab at this one? Should I rewrite the original equation before I do derivative? Okay, I'll do that. I'm assuming you meant only the second part, but maybe you meant the first part. So this would be what? Negative 2/3. Second power, cube root, negative because it was on the bottom. Okay, so now we can do derivatives. No, I think I heard you say pi is constants of 0. which is good thinking, except because it's being multiplied on something variable. This is called a scalar multiplier because it's just a number being multiplied on variable information. Scalar multipliers will follow into the derivative. So a multiplier of pi, its derivative will also have a multiplier of pi. If the number was by itself, then its derivative is 0. Because it's being used as a multiplier and not just a constant number on its own. So that's the main difference. What's the derivative of e to the x? E to the x, I know it's the best one. Okay, so then we gotta do the derivative plus, okay, plus 2/3. Negative 5/3, good, you guys are getting it down. This one looked very scary at the start, actually had very little work. Very opposite from the previous one, which looked easy but had a lot. Yes?
Could you explain, like, for in E, I tried it, and you get like ln 4x cubed. How do you do 4? Like,
we had done
Wait, are you talking about the problem we didn't do?
yeah.
Okay, so what did you want to explain?
How do you deal if it's like ln 4x cubed? How do you deal with the coefficient 4?
Okay, so when I'm looking at this, they're actually all multiplied. So there's 3 things being multiplied. So I would rewrite it as 3 different natural logs. Two of these natural logs have a power, which I would bring out front. And once you get good at it, you can do all of this on one step if you want. ln of e is just 1. So honestly, I can kind of, because it's times 1, it won't affect anything. I think you were asking mainly about the 4 though, right? So ln of 4 is just a number. Like if you type in your calculator, it's just a number. And if I'm doing the derivative of just a number, it's 0. So I'm actually not even going to do anything with it. I've got a scalar multiplier of 3, so that would follow into the derivative. Derivative of ln of x is 1 over x. Derivative of x is 1. And I couldn't, oh, actually I posted the notes yesterday. Didn't even think of that. That works perfect. Schoology wasn't working for me at all first hour, so I couldn't post anything for you guys. But I am recording it today because I know there'll probably be a bunch of people that need to watch it later. So if and when Schoology starts working, I do have the answer key posted for the notes and the practice. So yesterday you guys could probably only do like a third of the homework because I think it was power rule by itself was just not that many problems. A lot of them were mixed, and I would bet today when you look at them they probably shouldn't feel too bad. You know, we didn't have any trig ones though, did we? Do you want me to do a trig example? Okay.
The riffraff, yes.
We'll
See
be
your decimated.
Yeah. Yeah, we're finishing the notes section. No, I think they want to.
Do we need a little mental break?
I think every day is a break.
So it becomes habit now.
Glad to know you want.
What's secant squared? That's tangent for number 2. What do we have done?
Yeah.
Okay, so it'd be 3 squared.
Andrew, I think you're the only person I actually call on today.
Yeah, that's right.
I feel it's fair to let you call on that person.
Cody, for number 3 squared, when it's in the bottom,
No need to feel
does it
bad.
become 4x?
Well, it's like half the numbers are gone
I think
though. Oh, 26 is here, Matt is here.
I'm here. What's up? Who called on me? Andrew, bro?
That's my bad, that's my bad.
There's not really anything I can do to make trig one difficult.
Okay.
Just go back to that.
So I'll give you one example that includes everything.
What did I do?
How would I find the derivative of that?
Okay. Isn't it just 2 cosine x?
Perfect, so it has a multiplier, so it stays with the multiplier, yep.
Minus, wait, no, plus, because it switches, yeah, 3 sine x, and then plus secant squared.
Perfect. I know you guys are generally terrified of trig. Trig derivatives are super easy. Right. Yeah. They're predetermined derivatives, so it's not even something you figure out. You just already know what the derivative is. Okay, that honestly should cover just about anything that you should see in the homework. What do we got, 20 minutes left? I figured that would work good for you guys to be able to come up and ask questions. I was gonna try to call up people about grades, but I don't even know if I can access them or not, so. Oh, the tests.